Hey guys, welcome back to the channel. I know it's been a couple of weeks since I've uploaded the video. Thank you for coming back to watch this video. So I installed this service upgrade on April 5th. So it's really only less than 2 weeks ago. And as you can see, that meter again, not secured to the structure at all. The meter was in some rough looking shape, but otherwise, rust, obviously. This is the old service entrance cable going right through the concrete foundation, which is a violation now. So we corrected upon that. There's obviously no straps. Obviously, that's what happens when you have the vinyl siding guys put the service back after the vinyl siding's been installed. So I got up on top of this ladder, and it was a lot higher than I thought. This 24-foot extension ladder that I used was fully extended. But I was able to get up there and do what I got to do to cut out and then later cut in. You tell me, was that a good time to change the weatherhead in the service upgrade? Look at the exposed conductors behind the insulation there. Just completely missing. And just so you know, the way they made service entrance cable back then as compared to now is a world of difference. Back then it was more cloth, and today it's more like a PVC, like an oil-based covering. Much more reliable for sure. And so once again here, I'm just prepping my service head before I carry it up the ladder and secure it to the house. And of course, we know that the service head always has to be above the service hook. And the service hook is what suspends the aerial drop, service drop from the utility. So make sure that service head is above there. And that's what I'm doing here. So prepping, putting my butt splices onto the conductors now so I don't have to do it later when I'm up on the ladder tying in. Yes, I understand that not everywhere can you use the service entrance cable like this. I see the comments, I read the comments, and I appreciate them. But around here, this in the Northeast, this is how we do it. With this duct seal up on the top. Now you got to make sure that the duct seal is actually rated for indoor and for outdoor use. If it doesn't say outdoor use, it's not rated to be used outdoors, then you definitely will have problems in the short term. So make sure when you buy your duct seal, you read the listing on it and make sure it says for indoors and outdoor use. Otherwise, you can't use it outdoors. And in New Jersey here, some inspectors actually do look for that and want you to show them that the duct seal that you use is rated for outdoors. I've actually had that happen, so no problem. I wanted to go through this soffitted area instead of going through the foundation again like it was before. And I don't think I have it on the video, but I did come back here to do some other work, and I patched the old hole that the old service entrance cable went through to get to the panel. The reason why I do that is obviously I'd have to run some PVC through the wall, and now you got to get out a bigger drill and make a bigger hole, and I think a bigger mess. So what I did here was I went through what's known as the rim joist, and as you can see, there's a soffitted area hanging over the foundation right there, which is the living room on the one side. But this piping went down into the basement, and I just sleeved the 100 amp service entrance cable through the LB and left it ready for me when I got down to the basement in the afternoon to start working on the panel. So that's what we did here. It actually started getting pretty hot here on this day. I think it was one of the first hot days of the season here in New Jersey. The past couple days, and I'm talking to you on Friday, April 14th. The past couple days, it's been up into the 90s. I've even gotten to the side of my truck, and the thermostat inside of my truck, the display says 99 degrees. So that's how hot it is here the second week of April. But it is supposed to go back down to the 60s later this week, or next week, I should say. So just like with the 200 amp services, actually this is an 1.25 inch PVC conduit. And so I'm pushing the service entrance cable up, and then I'll take the bottom side here and push it in to the panel that's down the basement, which we'll see shortly. But just like with the 200 amp, it's still difficult, and I gotta bend it through this through this LB. I think I use a piece of PVC to bang to get that through, but it eventually goes through, and that's that. So tying in the meter, obviously on the top side of the meter is a set of lugs. There's 3 lugs, 2 hots and 1 ground. And then on the bottom side, there's also 3 lugs, 2 hots and 1 ground. The top side is always your line side, which is the power coming in from the utility. And then the load side is always on the bottom, which goes down to your panel. Once you put the meter in, you bridge those two circuits together, and they're able to calculate your electrical bill, and that's how the meter works. This is a PSE&G territory, so this 100 amp panel has the 5th jaw to monitor neutral current. We've been over that in previous videos. If you have any questions, leave them down in the comments below. Just like with the service entrance cable comments that we can't do that where I live, we need to use rigid, we need to do PVC, it looks nicer, etc., etc. The penetrox here, or rather the antioxidant, is not required, but I've been using this all my whole career as an electrician, so I use it. It prevents corrosion and oxidation, obviously, from happening on these conductors. It slows that process. So yes, in 70 years, it might be deteriorated, and it might be time for another service upgrade when it's 2090. But for now, we're going to do it to prevent that from happening. Hey, if you haven't already liked this video, please do that. Hit the subscribe button and the notification bell so you'll be notified when I upload videos. Thank you. The Federal Pacific Electric Company designed, patented, and sold circuit breakers, beginning with its first patent in 1949 and ending with its eventual bankruptcy. Its products were later found to be defective and dangerous. In 1979, Reliance Electric Company bought Federal Pacific Electric Company from UV Industries and was shortly thereafter bought by Exxon Corporation. But in 1980, Exxon sued, claiming that the UV Industries had faked safety tests to gain UL listings for its products, and UL withdrew its safety endorsement. The Consumer Product Safety Commission subsequently tested the products. Despite CPSC findings in 1984 that the circuit panels were faulty and dangerous, no recall was ever issued. Other independent testing indicated a failure rate of up to 60%, yet products still found their ways to shelves and continued to be sold. In 2002, a New Jersey court found in a class action lawsuit that Federal Pacific Electric Company had violated the New York Consumer Fraud Act by knowingly selling circuit breakers that did not meet UL safety standards, despite the UL endorsement on its label. Potentially hazardous Federal Pacific Electric Company circuit panels can still be found in millions of homes built before 1990. They can be identified by the red labels on the circuit panel's front or side. All right, so I got a little problem here. Not a huge problem, but I'm working in this house, and unfortunately the owner of this house is old, and she's going to be spending the rest of her life, I think, in a nursing home. I don't know all the details, but that's why I'm here fixing this panel and doing this upgrade, because of the Federal Pacific. It'd be hard to sell a house anyhow. So when I first came to look at this job on Saturday, I said to the homeowner that I was with, their son, what were these wires doing going into the earth outside by the panel, which I'll show you in a second. On the inside here, it's what this LB was. All right, this is the air conditioning. I got a separate neutral wire here from God knows what, and then I got a 240 volt circuit for the air handler, and another 240 volt circuit for the air conditioning condensing unit. It goes to the outside. So once we get outside, I'll show you what it does. All right, so I'm on the other side, the outside now, over by the panel. And you see this conduit here. This is what goes in to the panel. The LB I just showed you. Obviously you can see right there, it's cracked. And there's an LB fitting in there. God knows how it's still working after all that. But the condensing unit is over here. Okay. And you can see where it emerges underground over here. I don't know why they ran it underground, but they did. I'm gonna go see what's on the other side. I suspect it's just a disconnect, but I'm also gonna have to find the air handler. So I'm gonna propose just to run some new wiring for that, just to make it safe. Okay, so as I suspected, comes out of that junction box in the earth, comes to the disconnect, then the disconnect over to the unit, and that's fine. Comes out of here though with this EMT, and then goes up the wall all the way up to the attic with the line set. So that answers my question. So when I first start working on these panels, obviously I got to take the old panel out, which I've done here. Then what I want to do is I want to make sure that I'm able to fit my board. And obviously you see I got to cut out a bunch of this old paneling, including one of the studs. But this is our partition wall. It's not a load-bearing wall. And so it was okay to cut that out. As far as I'm concerned, somebody might say something that is not right. I get it. But once I get situated, I wound up using cutting the board down almost to the same size as the panel, so I can make this as compact as possible, so it's not a big mess. And then you see what I'll do is I'll slide the service entrance cable into the larger connector on the top, and I'll push the individual branch circuits right through the holes, and then I'll come back and I'll use those white button connectors again, or holes. I shouldn't say holes, they're knockouts up at the top. I take them out, I drag my circuit conductors through them, and then I come back later with my white button connectors. So each one of the individual Romex wires, or non-metallic sheet cable we like to call it in the trade, they all have connectors. The only conductors in the panel that don't require connectors are the grounding electrodes. And in this particular Cutler hammer panel, there are specific holes designed just for that grounding electrode conductors. And so in here I have two grounding electrode conductors, one that goes out to the ground rods and another one that goes to the water meter, which is so lucky for me that the water meter is right behind that door on the left, which was fantastic. It made for working and getting that work done quick. So I was able to do the service and the grounding electrodes here all on the same day. But it was a long day and it was a hot day. And I do believe that when I left, I didn't go home right away. I actually stopped at the Riverside Inn in Cranford. Shout out to my old buddy Jake. And I watched some Yankees for about an hour. I had a nice chicken sandwich before I drove home. I had a cold beverage or two, but not three. You don't want to drink and drive. So here, obviously, I start terminating. Once all my cables are in and the connectors are on, I'll start terminating the grounds and the neutrals first. And then I'll come back later on and install the circuit breakers. And as you can see, I just do that one at a time here. I know this is on a fast mode here, time lapse. Otherwise, this video might be 2 hours. And I don't know if you got 2 hours to spend with me talking about installing electrical services. I would assume that's kind of boring, but what do I know? I appreciate all your comments, though, that when you watch these videos, you learn something, because that really means a lot to me. So it should go without saying that when you go to put these circuit breakers in, you wonder what size circuit breaker should I put in for each conductor. Well, obviously for a 14 gauge conductor, it's a 15 amp breaker. And for a 12 gauge conductor, it's a 20 amp breaker. Now, there are a few exceptions, and some of those exceptions are for air conditioning equipment, but we'll get into that on another video. But for now, I just wanted to go over and clarify how I size my circuit breakers to the conductors on a service upgrade. If you have any questions about that, please leave them down in the comments for me. I'm more than happy to answer those questions. Thank you. So a grounding electrode that goes to the water main here to feed the copper water main electrode. It's we've been running number 6 wire forever, but what the code actually calls for 100 amp service is number 8 copper or number 6 aluminum. The reason why we don't run number 8 is it's more subject to physical damage, and so you would need to protect that conductor somehow, whether it's through a piece of conduit like PVC or some other means. So instead of running the number 8, which nobody really keeps on their truck, we run number 6, and that's not subject to physical damage. And I've been doing it that way for as long as I can remember. Okay, so there's the jump from the supply side to the customer side, which is required by the code. Over here at the water meter, where the hot water pipe meets the cold water pipe, there's a jumper. There was already a jumper in place that's much larger than 4 copper or 2 aluminum. Just wanted to make sure those terminals were tight. And now I'm ready to get back on the ladder here and bug in my service. So enjoy. So as I do on all my service upgrades, I check for line voltage, and then I check for continuity on the load side to make sure there's no continuity between anything, as long as that main breaker's off, so there's no short circuits or ground faults. Then I put the meter cover on, and obviously once the meter goes in and you have power to your load side, so the main breaker's been energized, you go downstairs to the panel and you turn the main breaker on, and then you turn on the individual circuits one at a time. And if you can you want to stand away so it's not right in front of your face here. And power's been restored. But the one thing I noticed that I didn't do yet was my ground rods. So here we go, ground rods. Ground rods are supposed to be spaced 6 feet apart from each other. So what I normally do is I take my 8-foot ground rods here, lay it flat, and then I know where to drive the second ground rod. So what you want to do is you want to push it in as far as it can go. And then I got a M18 SDS Max with a ground rod attachment to drive it into the earth. Very rarely do I have problems getting these ground rods all the way in, and there's no excuse to cut them short. Get the right tool or keep hammering, whatever you got to do, get those in. Even though they don't do too much, the grounding electrodes, the ground rods, they are required to supplement the water ground electrode. So that's why we got to drive them. We drive 2 of them. So here I'm just drawing straight lines. So when I drill these holes for my straps for my number 6 copper to the ground rods, it's a nice straight line and it looks like it's done in a workmanlike manner, which is important to me. What I'm installing here is what's commonly referred to as the bonding bridge. It's required on the outside of the house for grounding electrodes such as the electrode for your cable television splitter, or from your Ethernet splitter, or your DSL splitter, whatever you got going on out there, satellite dish, anything that's metal, we want to bond to the grounding system of the home, and that's what this bonding bridge is installed to do. If you haven't already, please hit that subscribe button. Thank you. Stuff like that before.
Yeah.
Anyway, this is the air conditioning I was telling you about.
Yes. Okay.
See this here?
Yeah.
That's not done right. That's a LB fitting like this. That's in the ground.
Okay.
I don't know why they would run across the ground here when they could run across the ceiling in the basement.
Yeah.
Which is what I'm gonna do.
Okay.
Alrighty, before I go, I'm gonna take off that cover and just peek at the size of the air conditioning.
Great.
And on the back there's a disconnect box. And so the air handler circuit and the condensing unit circuit are in the same contraption. We're going to get rid of it here, we'll get rid of it there, no longer be used. We're going to run new NM cables, Romex cables across the ceiling to the disconnect box.
Okay.
So nobody can say, hey, what's going on? So what do you think? I got it done. Another 100 amp service complete. Thanks for watching this video. We'll see you on the next one.